Before we go further with our discussion today, let us have activity number 1. Indicate a check mark in the table below the property that corresponds to the given quadrilateral. We have quadrilaterals, parallelogram, rectangle, rhombus, and square with numbers 1 up to 10 property. Let's start with number 1. All sides are congruent. Yes. Number 2. Opposite sides are parallel. That's correct. Number 3. Opposite sides are congruent. Yes. Number 4. Opposite angles are congruent. That's correct. Sub number 5. Opposite angles are supplementary. There you go. Number 6. Diagonals are congruent. Yes. Number 7. Diagonals bisect each other. That's right. Number 8. Diagonal bisect opposite angles. Yes. And number 9. Diagonals are perpendicular to each other. Indeed, that's correct. And lastly, we have a diagonal divides a quadrilateral into two congruent angles. That's correct. Again, these are the properties for the quadrilateral, specifically parallelogram, rectangle, rhombus, and a square. So this means that you are ready to proceed to the next level of our discussion. Let's take a look with this question. Which among the figure below do not belong to the group? The first figure, second, third, fourth, and fifth. So there are 5 figures here. So which among these 5 figures do not belong? Based from the given figures, figure 5 do not belong to the group. Looking into the figure, especially its sides, there is only one pair of parallel sides, unlike the other figures. This makes it unique, and we call this figure as trapezoid. That's why today we will be discussing Quarter 3, Week 4, Module 4, which proves theorems on trapezoids and kites. So our main objectives this discussion we would have: first, proves theorems on trapezoids and kites. Second, solve problems involving theorems on trapezoids and kites. And lastly, we have to discuss the value of being unique. Now it says that trapezoid or trapezoids are unique. In what way does trapezoids becomes unique? So based from these illustrations, a trapezoid is a convex quadrilateral with exactly one pair of parallel sides. Just like in that illustration, this side is parallel to that side. The first part of a trapezoid, we have the bases. So what does it mean when you say bases of a trapezoid? The bases of a trapezoid are the two parallel sides. In the illustration, you have it there, segment AB and segment DC. These are the two parallel sides. Now, when we are now going to solve problems, we will have a deal first that the length or the shorter in length or the shorter base will be considered as our base 1 and the longer base shall be considered as our base 2. Now let's proceed. We have now the legs of a trapezoid. These legs of a trapezoid are the two non-parallel sides. So meaning to say, they are not parallel. So if segment AB and segment DC are parallel sides, therefore, that segment AD and that segment BC are the non-parallel sides. DC is not parallel to segment BC. Next up, we have the median. So how does it look like when you say or illustrate median in a trapezoid? So what is median? The median of a trapezoid is the segment that joins the midpoints of the legs. So as we said a while back, segment AD and segment BC are the legs of the trapezoid ABCD. So if you're going to draw or illustrate, that is now our median. So shall we say that median is named as segment LN. So segment LN is the median of the trapezoid ABCD. Next up, we have what we called the base angles. So if you are going to take a look with our illustrations this time, you have there the mark red and the mark green. The base angles of an isosceles trapezoid are congruent. So meaning to say that angle A and angle B are congruent. And so with angle D and angle C. Remember, base angles are congruent. So once again, the bases, the legs, the median, and the base angles. And this makes the trapezoid unique. Now, when do you consider a trapezoid is an isosceles? Look into our trapezoid ABCD. Isosceles trapezoid is a trapezoid with congruent legs. That is, segment AD and segment BC shall be or should be congruent for you to say that trapezoid ABCD is an isosceles trapezoid. Now let's proceed to the different theorems of a trapezoid. Let's say theorem number one rather. The median of a trapezoid is parallel to its base and its length is 1/2 the sum of the lengths of the bases. If we're going to illustrate that one, as we agreed a while back, that the shorter in length or the shorter base shall be considered as our base 1 and the longer base or the side longer base is our base 2. So right there in our illustration that the median is said to be the sum of base 1 and base 2 divided by 2 or simply half the sum of the lengths of our bases. Now, let's try to prove that one here. Okay. Now, given trapezoid MINS with median TR, we are asked to prove that segment TR is parallel to segment IN. Segment TR is parallel to segment MS. Therefore, segment TR is 1/2 of the segment MS plus IN. So to prove that one, we will be using the two-column proof with the statements and the reasons. So, commonly, what would be our first statement? Okay, so trapezoid MINS with median TR. That would be our first statement with the reason that is given. Now, based from statement number 1, we can draw IS with P as its midpoint. What's the reason? And that is line postulate. For the third statement, you have there that segment TP is 1/2 of segment MS and TP is parallel to segment MS. What is the reason? That is midline theorem on triangle IMS. Now, what would be our next statement that the reason will give us the midline theorem on triangle INS? That would be segment PR is equal to 1/2 times IN or 1/2 of IN and PR is parallel to IN. That would be in number 5, segment MS is parallel to segment IN. And that is the definition of a trapezoid, where we can also have our statement that segment TP is parallel to segment IN. Definition of parallel or TP is parallel to segment MS and MS parallel to segment IN. For number 7 statement, segment TP and segment PR are both parallel to segment TP, parallel to segment IN. Thus, T, P, and R are collinear. What would be the reason? TP and PR are either parallel on the same line. That is definition of parallel. Right there, we can have then our statement that TP is equal to TP. For number 8, TR is equal to TP plus PR. That is segment addition postulate. That segment TR is just 1/2 of segment MS plus 1/2 of segment IN by substitution. If we're going to simplify it out, the statement number 9, you would have segment TR is equal to 1/2 of the quantity of MS plus IN, which is distributive property of equality. So right there, we have been proven it already that the median of a trapezoid MINS, which is our TR, is just 1/2 of segment MS plus segment IN. Now let's apply that one in a problem. Theorem number 1 example. Given PART is a trapezoid and segment XY is the median, we are asked to answer these 3 questions here. So let's take a look with our illustration here. As we agreed, the shorter base would gonna be, or the shorter length would gonna be our base 1. So this one is our base 1. And the longer base, or the longer side, will be considered as our base 2. And segment XY as being mentioned, that is our median. So let's start with problem number 1. If segment PT, where is PT? This one is unknown, and segment XY as the median is 11, and segment AR, this one is 7. We are asked to find segment PT. So for your solution, you would have, let's make our formula out from this illustration. So go back with the theorem. It says that the median of the trapezoid is parallel to its base, and its length is 1/2 the sum of the lengths of the bases. So our median here is, we have XY. So 1/2 of the sum of base 1 and base 2. So you have there segment AR as our base 1 plus our base 2 would be segment PT all over by 2. So this would be the formula that we're going to use as we are going to solve the unknown here. All right. So let's continue. So for number 1, let's just simply substitute. Segment XY is 11. Okay. And is equal to segment AR, which is 7, our base 1, and we're looking for segment PT, the base 2, all over by 2. So to simplify, you can apply cross multiplication here. Okay, so this is over 1. So 2 times 11, that would give you 22, is equal to 7 plus PT. Okay, so since we're looking for the segment PT, you're going to apply subtraction property of equality, wherein 7 will be transferred on the other side, that would becomes negative. So in the same manner, you would have PT is equal to 22. So 7, negative 7. Is that clear? Now, what is 22 minus 7? That will give you 15. So meaning to say, segment PT is equivalent of 15 units. Is that clear? That's number 1. Let's now proceed with problem number 2. It says that segment PT is 25 and the median is unknown, and segment AR is 13. Okay, so we'll just go back with our formula since they are on the same illustration. So we'll just simply substitute We're looking for segment XY, so there's no value there. Equals, AR is how much? That is 13. Plus 25 over 2. So simplify, since we're looking only for the value, the length of segment XY, you would have 13 plus 25 will give you 38 over 2. So again, 38 divided by 2, that will give you 19. Okay, therefore, the median of the trapezoid PART is equal to 19 units. So this is 19. So for number 3, you would have segment PT, where the base 2 is 21, and segment XY, as your median is 13, and we're looking for the base 1. So still, you will be using this formula, ha? Okay, so therefore you would have segment XY, which is 13, equals the base 1 is unknown, plus the base 2, which is 21 over 2. Alright, so to simplify, you can apply cross multiplication. So you would have 13 times 2 will give you 26 equals AR plus 21. So apply subtraction property of equality so that you could transfer positive 21 on the other side. You would have AR equals 26 minus 21. So what is 26 minus 21? The answer is 5. So segment AR is equal to 5. Let's now proceed to theorem number 2. So for theorem number 2, the base angles of an isosceles trapezoid are congruent. So right there in our illustration, that we have angle P and angle L, the base angles. Angle N and angle A are the base angles. Right there, it says that the base angles of an isosceles trapezoid are congruent. So therefore, you could say that angle P is congruent to angle L and angle N is congruent to angle A. Now, let us prove that one here. Given that isosceles trapezoid AMOR, MO is parallel to ER. We are asked to prove that angle A is congruent to angle R. Angle AMO is congruent to angle O. So what would be our first statement, where the reason is always given? Well, you have it there. Isosceles trapezoid AMOR. So what would be our second reason if we would have segment AM is congruent to segment OR? Segment MO is parallel to segment AR. That would be the definition of an isosceles trapezoid. Right there, we form, or from M, draw segment ME parallel to segment OR, where E lies on segment AR. That would be parallel postulate. What would be our next statement with the reason definition of a parallelogram? Well, right there, segment MORE is a parallelogram. From segment MA is congruent to segment OR, therefore, that is parallelogram property. And aside from that, segment OR is congruent to segment ME. That is symmetric property. Now, based from the reason, transitive property, from the statement number 2 and 6, connections, that would give you that segment AM is congruent to segment MA. And therefore, you can have the next statement, the triangle AME is an isosceles trapezoid. Not trapezoid, rather. Triangle, rather. Definition of an isosceles triangle. Right there, since we talk about isosceles triangle, you can have that angle 1 and angle A are congruent. That is, base angles of an isosceles trapezoid are congruent. And for number 10, The angle 1 is congruent to angle R by corresponding angles are congruent. So for number 11, you would have angle R is congruent to angle A. That is substitution. Angle A is congruent to angle R. That will have a reason symmetric property. In number 13, you could have conclude that angle A and angle AMO are supplementary angles. And angle O and angle R are also supplementary angles. Right there, interior angles of the same side of the transversal are supplementary. Lacking S there. They are now supplementary angles. So therefore, as a conclusion, as a whole, angle AMO is congruent to angle O. That is, supplements of congruent angles are congruent. So let's apply that one in a problem. So let's now have theorem number 2 example. With an isosceles trapezoid TRAP, where angle T is 115 degrees and segment TR is parallel to segment PA. And at the same time, segment TP is congruent to segment RA. So this is an isosceles trapezoid. Now, we are asked to find the measure of angle R. Okay, so where is angle R there? So here is our angle R. So from the theorem, it says that the base angles of an isosceles trapezoid are congruent. So from the illustration, which one is our base angles? So you have it there. Angle T and angle R are the base angles. And angle P and angle A as well. So take note that angle T is 115 degrees, meaning angle R will also be 115 degrees because of theorem number 2. Is that clear? So this one now is 115 degrees. So no need for us to show our solutions. So for letter B, if measure of angle B, not B rather, measure of angle A rather, is equal to x minus 2 and measure of angle P is equal to 78 degrees. We are asked to solve for x. So here is our angle A, which is x minus 2 and angle P is equal to 78. So these are base angles, meaning they are congruent. So in that way, you can say measure of angle A is equal to the measure of angle P. So substitution, you would have x minus 2 as your measure of angle A equals 78. And you are just looking for the value of your x, right? Since we are asked for. So you would have x equals 78. Applying addition property of equality, the negative 2 will be transferred on the other side. That becomes positive. So 78 plus 2 therefore is equal to 80. So the value of our x now is equal to 80. Is that clear? So to double check, if you really want to check, okay, how much is the measure of angle A? If you really want to check that they are congruent, so just substitute measure of angle A equals x minus 2. So what's the value of your x? That is 80. So minus 2, you would have 78. So they are just congruent. Okay? Let's now proceed to theorem number 3. For theorem number 3 states that opposite angles of an isosceles trapezoid are supplementary. So based from our illustration here, trapezoid CLAN or clan. You have there, if you would have angle C, what angle is opposite to angle C? That would be angle A. And angle N is opposite to angle L. That's what meant by that figure there. Angle C and angle A angle N, and angle L. These are the opposite angles. So if these are the opposite angles, therefore, if you would have the measure of angle C plus the measure of angle A will be equal to 180 degrees. Same as with measure of angle N plus measure of angle L is equal to 180 degrees. Let's find out in our problem. Later on, I will show you a sample of that problem, but this time we will have to prove that it's really true that the opposite angles of of an isosceles trapezoid are congruent. So from the given isosceles trapezoid ARTS, we are asked to prove that angle ARS and angle S are supplementary. Try to take a look with the illustration. Next up, angle A and angle T are supplementary as well. So it means they measures 180 degrees. Now what will be our first statement that we will always have a correct answer? Well, it's there. Isosceles trapezoid ARTS is coming from the given. Okay, what will be the reason for number 2 statement? That is segment AR is congruent to segment TS and segment RT is congruent to segment AS. Well, definition of an isosceles trapezoid. So from there, or from R, draw segment RE is parallel to segment TS where E lies on segment AS. And that is parallel postulate. Segment REST is a parallelogram. Definition of a parallelogram. Therefore, segment TS is congruent to segment RE. And that is parallelogram property. What will be the next statement? That we always have in the given as transitive property based from the previous statements. You have segment ER is congruent to segment RE. Transitive property. In that way, triangle ARE is an isosceles triangle. Well, of course, definition of an isosceles triangle. In that way, angle 3 and angle A are congruent. Remember, that is base angles of an isosceles triangle are congruent. So, measure of angle 1 plus measure of angle 3 plus measure of angle A, you would have the interior angle sum theorem on triangle. So for number 10, you have angle 3 is congruent to angle 2. That is alternate interior angles are congruent. So angle A is also congruent to angle S. That is referring to theorem number 2 about base angles. Now, measure of angle 1 plus measure of angle 2 plus measure of angle S will give you a substitution for the statement number 9, 10, and 11. That's why angle 1 plus measure of angle 2 is just equal to angle ART, angle addition postulate. In that way, measure of angle ART plus measure of angle S will give us a substitution. Another substitution, that would be interior angle of the same side of the transversal are supplementary. And for number 16, you would have substitution, and we therefore have that angle ART and angle S are supplementary, and angle A and angle T are also supplementary by the definition of supplementary angles. Now let's find out in our problem. Okay, so problem number 3, you have it there. There you go. So let's now have theorem number 3 example. We are asked to find the measures of measure of angle X and measure of angle Y from this illustration. Assume that this trapezoid is an isosceles trapezoid with an angle of 65 degrees, 115 degrees, angles x and y. Going back to the theorem, it says that opposite angles of an isosceles trapezoid are supplementary. So in this case, if you would have angle 115 degrees, what is the opposite angle to this? That would be angle x. So we can therefore formulate our equation to solve for the measure of angle x. So solving for measure of angle x, you would have an equation 115 degrees plus measure of angle x is equal to 180 degrees. Then, you will apply subtraction property of equality so that you can solve for x. And that would be measure of angle x is equal to 180 degrees minus 115. And that will give you measure of angle x is equal to 180 minus 115 will have 65. So that's the measure of angle x. Now, how about the measure of angle y? So from there, you have their angle y. What is opposite to angle y? And that is 65. So to formulate our equation, you would have solve for measure of angle y. So you have 65 plus measure of angle y rather equals 180 degrees. So solving for y, measure of angle y is equal to 180 minus 65. So 180 minus 65 will give you 115. That would be the measure of angle y. Is that clear now? So opposite to this one is, these two are opposite angles, so meaning they are supplementary, so meaning this would be 115 degrees and that one will also be 65 degrees. Now if you're going to go back to theorem number 2, base angles of an isosceles trapezoid are congruent, so 65 and x are base angles, so meaning they are just equal. Now let's proceed to the next figure. Okay, so in this figure we still assume that this is an isosceles trapezoid with an angle measure is, one of the angle measure is x degrees and 72 degrees. So they are opposite angles. So we are asked to solve for x. Alright, so opposite angles you would have, so there you go. We have solving for x. Okay, solve for x. So they are opposite angles, so you can make 72 plus x is equal to 180 degrees. So x is equal to 180 minus 72. So x therefore is equal to 180 minus 72 will have 108 degrees. So that's the measure of angle x. Okay, now let's proceed to problem letter B. If x is equal to y plus 10, so this one, what is the measure of the opposite angle? So there's a twist. So the x here is y plus 10. So in that way, we still have we can have this formula or equation. So that still be 72 plus x equals 180. And then there's a twist that x is equal to y plus 10. So you would have 72 plus y plus 10 equals 180. Okay? So let's simplify. You would have 72 plus 10, you would have 80. So y plus 82, not 80, it's 82, equals 180. So to solve for y, you would have y is equal to 180 minus 82. Again, 180 minus 82 will give you 98. So y value is equal to 98. Alright. So in that way, how much is the measure of angle y? If we have solved already the unknown value of y, which is 98. So measure of angle x, which is y plus 10, would have, okay, I'm sorry. So again, measure of angle x is equal to y plus 10. So the y value is 98. So substitute 98 plus 10. You will have 98 plus 10. That will give you 108. So that's the measure of angle x. Is that clear now? So from there, it's 72 and 108. If you're going to combine them, that would be supplementary. What is 72 plus 108? That will give you 180. Is that clear? At this point, let us now proceed to theorem number 4. What does theorem number 4 states? It says that the diagonals of an isosceles trapezoid are congruent. Let's look into our illustration this time. Trapezoid SEND with segment SN and segment AD as the diagonals. Therefore, segment SN is congruent to segment DA. Let's prove that one. Given isosceles trapezoid ROMA, and we are asked to prove that segment RM is congruent to segment AO. Please look into our illustration. So our first statement, of course, you have there isosceles trapezoid ROMA. That's given. So number 2 statement, you would have segment OR is congruent to segment MA. That is definition of an isosceles triangle. In that way, angle ROM is congruent to angle AMO. That's theorem number 2. Meaning, if you could still remember, base angles of an isosceles trapezoid are congruent. So for number 4, segment OM is congruent to segment MO. That is reflexive property. They're just congruent to itself. Then, you have triangle ROM is congruent to triangle AMO. SAS congruence postulate. For number 6, we will now be able to prove that segment RM is congruent to segment AO. That is CPCTC. What is CPCTC stands for? Corresponding parts of congruent triangles are congruent. So let's now move on to example. Theorem number 4 example, we have here an isosceles trapezoid MNRP with diagonals NP and segment MR. So, we have problem number 1. If segment MR is 7.8 cm, find segment NP. Take a look with the illustration. As it being mentioned in the theorem that the diagonals of an isosceles trapezoid are congruent. So, in this case, segment MR is 7.8, therefore segment NP will also be equal to 7.8. So this one is 7.8. So there's no need for us to show our solutions here. So 7.8 centimeter. Now let's proceed to letter B. If segment NP is equal to 2x plus 3 and segment MR is 4x minus 5, we are asked to find now how long are they. So this would be now a simple twist. Now, going back to the theorem, they are congruent. So in that way, we can say rather, segment NP is equal to segment MR. By substitution, segment NP is 2x plus 3 equals segment MR is 4x minus 5. Okay, simplifying, you would have to combine similar terms. We have 2x and 4x. So, positive 2x will be transferred on the other side applying subtraction property of equality, and negative 5 will be transferred also on this side applying addition property of equality. So, in that way, you would have 4x as we transfer, that becomes negative 2x equals, so 3, negative 5 will be transferred, will be positive 5. Okay? Next, Simplify. 4x minus 2x will give you 2x is equal to 8. And since we're looking for the value of our x alone, since we have 2 as the numerical coefficient, you have to divide the whole equation by 2. And that is x therefore is equal to 4. And that's the value of your x. But take note, the problem here, we are asked to find the length of segment NP and segment MR. So, you are going to substitute that value to the segment NP. Okay, let's have that one first. 2x plus 3. So, our x is 4. So, 2 times 4 plus 3 will have 2 times 4 is 8 plus 3 will have 11. So segment NP therefore is equal to 11. Now how about segment MR? So segment MR, we have 4x minus 5. Substitute the value of your x, which is 4. So 4 times 4 minus 5. So what is 4 times 4? Is 16. Minus 5 will have 11. That is segment MR. So take a look with their values. Are they congruent? Yes. Because it says the diagonals of an isosceles trapezoid are congruent. Now, have you ever tried to play a kite? So right there in our illustrations, some of those children are playing kites. So what is a kite? So when we say kite, it is a quadrilateral with two pairs of congruent and adjacent sides. Looking into the illustration, you have it there that segment TE and segment TI, segment EM and segment IM are the congruent and adjacent sides. In segment TM, that one, we will consider that one as our diagonal 1. In segment EI, we will consider that one as our diagonal 2. So we have here the kite theorems. We'll have theorem number 5. For theorem number 5, it says that the diagonals of a kite are perpendicular to each other. Do you agree that from this illustration, kite TANK with point S or segment AK is perpendicular to segment TN at point S. So it forms right angle right there. Since we're talking about perpendicularity, so the angle, let's say angle TSA is a right angle. So with the other angles, you have angle ASN. Let us prove that one here. Given that kite WORD with diagonals WR and OD, we are asked to prove that segment WR is perpendicular to segment OD. Look into the illustrations this time. What would be our first statement? Well, kite WORD with diagonals WR and OD, that would be our first statement with a given reason. Number 2, WO is congruent to WD. OR is congruent to DR. And that is by the definition of a kite. Segment WO is equal to WD. OR is equal to DR. And that is definition of congruent segments. In that way, WR is perpendicular to segment OD if a line contains 2 points, each of which is equidistant from the endpoints of a segment, then the line is perpendicular bisector of the segment. So let us now have that one in a problem later on. But before that, we will have theorem number 6 that states that the area of a kite is half the product of the lengths of its diagonal. So here is our kite. We have diagonal 1, and that would be our diagonal 2. So from there, area would gonna be the product of the lengths of its diagonal. We have the diagonal 1 times diagonal 2 all over by 2. So let's have that one in a problem later on. But we will prove this time kite ROPE. That's the given kite, where the area of the kite ROPE is just one half of segment OE and segment PR. Please look into our illustration. Okay, you see that one. Okay, what would be our first statement? So the first statement we would have, of course, kite ROPE. That's given. Number two statement, we have segment PR is perpendicular to segment OE. The reason would be the diagonals of a kite are perpendicular to each other. For number three, area of a kite ROPE is equal to the area of a triangle OPE plus the area of triangle ORE. And that is area addition postulate. Okay? For number 4 statements, you would have therefore that the area of triangle OPE is one half of the segment OE times segment PW. And so with area of a triangle ORA is also equal to one half times segment OE times segment WR. The reason? Area formula for triangles. For number 5 statement, that the area of the kite, as we are going to combine them from statement number 4, ROPE is equal to one half of segment OE times segment PW plus one half of segment OE times segment WR by substitution. And as we combine them together, you would have the area of the kite, ROPE, is equal to one half times OE times PW plus WR. And that is distributive property of equality. In that way, as we simplify, the PW plus WR is equal to PR. Well, segment addition postulate. In that way, we have been proved that area of the kite ROPE is just one half of segment OE times segment PR by substitution. Let's find out in the problem. So this is now the problem. Next up, we have theorem number 5 example. And we are going to solve the following problem. Let's have number 1. The diagonals of a kite have lengths of 13 centimeter and 9 centimeter. Find the area of the kite. So if you're going to illustrate, the kite would gonna be this way. Okay. It's perfect. Alright. So in this case, we have here, as we agreed, that the longer in length will be considered as our diagonal 2. And the shorter in length will be considered as our diagonal 1. Okay, so remember that the area of the kite formula, you have diagonal 1 times diagonal 2 divided by 2. Because it says from the theorem that the area of the kite is half the product of the lengths of its diagonal. So let's go back with our problem here. So we have from the given, our diagonal 1 is how much? So 9 centimeter. And our diagonal 2 is 13 centimeter. And we're looking for the area of the kite. Okay. So for our solution, you would have, just simply substitute to the formula. So our kite, area of the kite is equal to, what is our diagonal 1? So our diagonal 1 is 9 rather, 9 centimeter times diagonal 2 is 13 centimeter. over 2. Okay, simplify. So what is 9 times 13? So that will give you 117. Centimeter times centimeter. That will give you centimeter square over 2. So we can divide this 2. You will have 117 divided by 2 will give you 58.5 centimeter square. And that would be then our area of the kite. Is that clear? Okay, so let's now proceed to problem number 2. Okay, so here is our illustration. So find the area of the given kite. Let's start with this kite. We have the kite A, B, C, D. With the lengths of the diagonals AC, okay, this one is equal to 12, and BD is equal to 7 centimeter. So once again, as we agreed, the shorter in length will be considered as our diagonal 1, and the longer in length would be our diagonal 2. Anyways, they're just the same. So let's start with this problem. The area of the kite. What's the name of our kite? Kite A, B, C, D. So we will not write anymore as kite. So you would have A, B, C, D equals D1 times D2 over 2. So our D1 rather here is how long? That is 7 centimeter. And our D2 is 12 centimeter. And we are asked to find the area. Okay, so by substitution, you would have 7 centimeter. It's okay also that you're not going to write anymore the centimeter here. You will just write on the final answer. Anyways, when you're going to multiply centimeter by centimeter, you will always have a centimeter squared. Okay, but anyways, we have written it already. It's okay. So you have 12 centimeter over 2. So to simplify, what is 7 times 12? That will give you 84. So centimeter square over 2. So the area of the kite A, B, C, D will be 84 divided by 2 will give you 42 centimeter square. Okay, so that's the answer for the kite of kite A, B, C, D. Now let's proceed to the second figure. Okay. On the second figure, it says that segment MO as diagonal 2 is 18 centimeter and segment PN equals 9 centimeter. So we'll just go directly by substituting from our formula. So you have area of the kite. What's the name of our kite? MNOP. It's gonna be up to you. MNOP equals diagonal 1 times diagonal 2 over 2. So what is the diagonal 1 here? The shorter length. That's 9. So we don't need to write anymore the centimeter. Anyways, it's okay. Then you have 9 times 18 over 2. So again, 9 times 18 will give you 162 over 2. So as we divide, 162 divided by 2 will have 81 centimeter square. So just like what I said to you, you will just simply write centimeter square in your final answer. So you would have area of the kite MNOP. So let us now the individual task for activity number 14. What's more? So the directions here, you're going to consider the figure below and answer the questions that follow. Given that quadrilateral MATH is an isosceles trapezoid with bases MA and HT. LB is the median. Okay? So at this point, I'll be giving you 10 minutes to answer this one. And so with the second slide, there you go, the second slide. So with the directions, consider the figure that follows and answer the given questions. Given that quadrilateral PLAY is a kite. So 10 minutes starts now. So here are the answers of our activity. So number 1, right there, y is equal to 3. Apply theorem number 1, MA is equal to 7, HT equals 10. For number 2, that is 115, theorem number 2. For number 3, we have x is equal to 35. Apply theorem number 3. Measure of angle MHT equals 115 and measure of angle MAT equals 65. Apply theorem number 3. For question number 4, you have there y is equal to 4. Apply theorem number 4. Each diagonal measures 13. Apply theorem number 4. And for letter B exercise, number 1, the answer is 36. Apply theorem number 6. Okay. Apply theorem number 6. Okay, balik. So for letter B, you have it there, number 1. Area is 36 centimeters square. Apply theorem number 6. Apply theorem number 6. For number 2, you have it here. PA equals 30. Apply theorem number 6. Apply theorem number 6. this module, we will have the performance task. We call this task as let's make and play. So here are the mechanics. Number one, individually, you will make a kite with a given length of diagonals. Okay, you have there the figure. Second, you will document your output from the start to end. Always refer to the given rubrics. As you're going to document, you can take pictures as you started making the kite, and then also right after you played the kite, or you could do a video presentation, could be. Third, you will test and play the kite. All right? So, game. So for your assignment this week, you will answer this activity number 15. What have I learned? There you go. And so with the post test, you'll be answering this one in a one whole bond paper, either long or short. So you don't need to show your solutions, but instead you have to follow what is in the given instructions or directions. Okay? So, thank you so much and God bless us all.